All right, you are welcome again. Let's talk about complex number. Under complex number, let's treat modulus in complex number. Modulus in complex number. Now, let's take this diagram. You can see this diagram, right? We have our x-axis and then we have our y-axis. And then let's see that we have x here and then we have y here. So this line, we call it the resultant. The word r, we call it the resultant. Under vector, this r simply means the magnitude, the resultant. Okay? Now, in complex number, the resultant r is called the modulus, or we can call it magnitude. Okay, good. Now, how can we find the what? The magnitude. How can we find the what? The magnitude. So you discover that in Pythagoras theorem, you can see that r will simply give us square root of x squared plus y squared. You know, we can see that r is our what? Our hypotenuse, y is our opposite, and x is our what? Adjacent. To get our hypotenuse, which is r, we'll simply say opposite squared plus adjacent squared. So after squaring them, we take their square root. Okay, we add them together and we take their square root. So we can simply say that r, which is our modulus, to find it, we can easily say the square root of x squared plus y squared. You get your x squared, then your y squared, you add them together, then take the square root of it. That is our what? Our modulus, r. Now let's, for instance, find the modulus of the following complex numbers. z1 equal to 2 square root of 3 minus 2i. z2 equal to minus 1 plus square root of 3i. z3 equal to 3 plus 5i. z4 equal to minus 5 plus 4i. z5 equal to minus 2 minus 3i. How can we find their magnitude or their modulus? Okay, in complex number we call it the modulus, which is the r, and then generally the r, you got it from the word resultant. You get it? Okay, now let's go. z1 equal to 2 square root of r minus 2i. So we have our r to be square root of x squared plus y squared. Now let's go. R is equal to our x squared. We have our x in z1 to be 2 square root of 3. So 2 square root of 3 squared plus we have our y minus 2. Let's take the square of it. Okay, now 2 square root of 3 squared is going to give us 12, and then minus 2 squared is going to give us 4. So we have square root of 12 plus 4. 12 plus 4 will give us 16. That means we have square root of 16. So the square root of 16 is 4. So therefore, the r of z1 is equal to 4. Now let's go again. z2. We have z2 to be minus 1 plus square root of 3i. So let's go. We have r is equal to square root of x squared plus y squared. So in z2 we have our x to be minus 1. Let's take the square of it, plus we have our y to be square root of 3. Let's take the square of it. Now we're gonna have square root of, when we say minus 1 squared is equal to 1, and then square root of 3 squared is equal to 3. So therefore we have square root of 1 plus 3 equal to square root of 4. So square root of 4 is 2. So therefore the modulus of z2, which is minus 1 plus square root of 3, r is equal to 2. Okay, good. Let's take number 3, which is z3. So we have z3 to be 3 plus 5i. So we're going to have r is equal to square root of x squared plus y squared. So here we have our x to be 3, and then we have our y to be 5. Okay, now let's go. We're going to have square root of 3 squared plus 5 squared. So when we say 3 squared equal to what? 9, and then 5 squared equal to 25. So we have square root of 9 plus 25, which is square root of 34. So therefore, our r of z3 equal to square root of 34. Now let's go z4. We have z4 to be minus 5 plus 4i. So our r is going to give us square root of x squared plus y squared. So we have our x to be minus 5, then our y to be 4. Okay, so we're going to have square root of minus 5 squared plus 4 squared. So minus 5 squared is equal to 25, and then 4 squared is equal to 16. So we have square root of 25 plus 16. We're going to have square root of 41. So therefore, the r of z4 is equal to square root of 41. So let's also take the last, which is z5. So we have z5 to be minus 2 minus 3i. So our r is going to give us square root of x squared plus y squared, and then we have our x to be minus 2, we have our y to be minus 3. Okay, so that means we're going to have square root of minus 2 squared plus minus 3 squared. So minus 2 squared is equal to 4, minus 3 squared is equal to 9. So therefore we have square root of 4 plus 9 equal to 13. So therefore our r is equal to square root of 13. So the r of z5 is equal to square root of 13. All right, thank you very much. Please, if you have not subscribed, please just click the subscribe button, and also remember to turn on the notification. All right, thank you very much.